Will the maritime power dynamics in the Western Pacific be completely reshaped by a few blurry images from Dalian Shipyard? When a Japanese think tank released that sensational satellite imagery in late 2025, this question weighed heavily on the minds of international military observers. The narrative of China's aggressive occupation of the South China Sea, long hyped by certain forces, now appeared feeble and powerless in the face of this hard-hitting industrial evidence. Never before had the world's gaze been so intensely focused on that bustling shipyard in northeast China. Within its massive dry dock, two colossal steel structural components, each approximately 18 meters long and of unusually heavy construction, rested silently on their building bases. Their distinctive shape and layout instantly caught the breath of anyone familiar with aircraft carrier construction history. After meticulous comparison with publicly available footage of early-stage construction of U.S. nuclear-powered carriers, particularly the Ford class, the conclusion is nearly indisputable. These are highly likely the massive protective casings for nuclear reactors, the steel heart of the carrier. Their emergence acts as a key, formally announcing that China's long-awaited nuclear-powered aircraft carrier has transitioned from blueprints and rumors into the most critical phase of physical construction, commonly referred to externally as the Type 004. The positioning of these two colossal structures signifies that nuclear energy, capable of propelling a nation's oceanic ambitions, now flows through its veins. This represents not merely a shift in propulsion type, but a strategic leap from quantitative to qualitative transformation. Looking back at conventionally powered carriers, whether China's Liaoning or Shandong, their outstanding combat achievements have always been constrained by a fundamental physical limitation: endurance. With full fuel and aviation kerosene supplies, they can operate at maximum capacity for approximately 40 days at sea before requiring a return to port for resupply. This acts like an invisible clock, constantly ticking down, severely limiting their ability for prolonged forward deployment and sustained high-intensity operations. Nuclear propulsion fundamentally reshapes the rules. A single nuclear fuel load can sustain full power operation for 25 to 30 years, nearly matching the carrier's entire service life. This means that from the moment it enters service, as long as personnel and supplies are replenished, it becomes a mobile territory perpetually patrolling the high seas, pushing the Navy's strategic reach deep into the blue waters. The increasingly routine and systematic exercises of Chinese naval task forces in the Western Pacific reflect this ultimate pursuit of unlimited endurance. The Type 004's hull framework, estimated at 43 meters wide, and its projected full load displacement exceeding 120,000 tons, are not only designed to carry more aircraft and ammunition but also to accommodate this massive and complex nuclear propulsion system and the near-luxurious electrical freedom it provides. The technical path for this power core has sparked intense speculation among the world's top defense technology circles. The most robust and feasible approach undoubtedly involves scaling up and optimizing China's mature pressurized water reactor technology, accumulated over years of nuclear submarine development, to meet aircraft carrier requirements. This solution presents relatively controllable technical risks, and key data validation is believed to have been achieved through land-based prototype reactor experiments in locations like Lashan, Sichuan. Yet China's ambitions extend far beyond mere catch-up. Another more cutting-edge and revolutionary option, the thorium-based molten salt reactor, may be accelerating on a parallel research track. This fourth-generation reactor type, utilizing liquid fuel and operating at atmospheric pressure, eliminates the nightmare of traditional core meltdowns at its physical core. Its theoretical thermal efficiency exceeds 50%, demonstrating astonishing potential in power density and safety. Regardless of which path the Type 004 ultimately chooses, the outcome remains consistent: a powerful, stable, and virtually inexhaustible energy source. The immense electrical power it delivers will form the bedrock of all modern shipborne combat systems. Electromagnetic catapults will no longer be constrained by peak power limitations, enabling more precise and efficient launches of diverse fighter aircraft. Future high-energy systems destined for naval deployment, such as laser-directed energy weapons and electromagnetic railguns, will gain reliable power assurance. Nuclear propulsion empowers the entire combat system, elevating its capabilities from adequacy to abundance, even to the point of extravagance. A powerful heart demands a robust torso and agile limbs to match. The combat design of the Type 004 embodies the full realization of the supercarrier concept. Thanks to the nuclear propulsion system eliminating the need for massive smokestacks and intake, exhaust ducts, the island structure achieves revolutionary downsizing, estimated to be over 30% smaller than conventional carriers. This more compact, stealthier island, combined with an extremely optimized deck layout, frees up exceptionally valuable operational deck space. Clear satellite imagery reveals 4 distinct launch rail tracks on the flight deck. These represent China's matured electromagnetic catapult technology, validated on the Fujian carrier, likely utilizing an advanced and reliable medium-voltage direct current integrated power system. The engineering maturity of this system is evident from the Fujian's successful sea trials, with its failure rate believed to be significantly lower than that of the U.S. Ford-class carriers, which employed earlier medium-voltage alternating current technology. The efficient catapult system, combined with optimized operational procedures, enables the Type 004 carrier to achieve an astonishing estimated daily sortie capability of approximately 270 sorties. This represents a roughly 35% increase over the Fujian's theoretical capacity, meaning it can unleash more intense and sustained aerial firepower against adversaries during critical moments. Soaring from these 4 catapult tracks will be the most powerful carrier air wing in the history of the Chinese Navy. The stealthy J-35 fighter will gain significant advantages over the F-35 fleets deployed by neighboring nations in situational awareness, beyond visual range air combat, and cyber warfare capabilities. The KJ-600 early warning aircraft, equipped with a high-performance gallium nitride active, phased array radar within its large radar dome, will establish a long-range surveillance and command network far surpassing enemy early warning aircraft. More disruptively, the integration of stealthy, unmanned combat aircraft like the GZ-11 will make manned, unmanned collaborative operations a reality. These systems can execute high-risk forward reconnaissance, electronic suppression, and even first-wave precision strikes, dramatically expanding the carrier's tactical dimensions. Such an air power, shielded by the stealthy escort of Type 095 attack submarines, and bolstered by the regional air defense and land attack capabilities of Type 055 destroyers, forms a complete carrier strike group. This is no longer a mere naval formation, but a truly intelligent, mobile military fortress. The transformation heralded by the Type 004 carrier extends far beyond naval shipyards, rooted instead in a nation's industrial backbone. China's aircraft carrier development has progressed steadily through 3 decisive phases, from retrofitting existing vessels to independently designing and constructing conventionally powered carriers with electromagnetic catapults, and now advancing to nuclear propulsion. Each step demonstrates systematic industrial capability and unwavering strategic resolve. Particularly striking is the efficiency embodied by its construction pace. Reports indicate the assembly of its massive hull modules took only about 10 months, a stark contrast to the 18-month-plus cycles typically required for similarly complex U.S. projects. This achievement stems from highly mature modular construction techniques, a comprehensive and efficient supply chain system, and a vast pool of highly skilled industrial workers. While the U.S. Navy grapples with frequent malfunctions in the electromagnetic arresting system of its Ford-class carriers, debates over budget overruns and schedule delays for its next-generation carriers, and even worries that its declining civilian shipbuilding industry cannot support the demands of powerful military vessels, China's shipbuilding bases in Dalian, Jiangnan, and elsewhere are leveraging the world's most active civilian ship market to hone world-class shipbuilding techniques and supply chain management capabilities. This deep, healthy, and vibrant industrial foundation is the ultimate guarantee that will carry the Type 004 aircraft carrier from concept to the open seas.